Okay, 17. A box of mass 6 kilograms lies on a rough plane inclined at an angle of 30 degrees to the horizontal. The box is held in equilibrium by means of a horizontal force of magnitude P as shown in the diagram. The line of action of the force is in the same vertical plane as the greatest slope of the plane. The coefficient of friction is 0.4. The box is modelled as a particle, given that the box is in limiting equilibrium and on the point of moving up the plane. Okay, let's just draw this out again. Right, 6 kilograms, you're going to have the weight component is 6g. The angle of inclination is 30. You've got the normal reaction. This is a pushing force, which I much prefer to draw as a pulling force. You don't have to. Okay, and it's about to move up the plane. Okay, normal reaction, the value of P, show that the box will start to move down. The horizontal force is now removed. Right, okay, so it's about to move up the plane, it said, and I put moving up the plane. So I've got F max, and it is F max because we're in limiting equilibrium. Is acting like that. First things first, I've got to componentalize this and this. And the second bit is I've got to componentalize the weight to a bit going like that and a bit going like that. So let's write the components on. I end up with this being also 30 degrees because it's a corresponding angle. This gives you P cos 30, and the force going downwards is P sin 30. Okay, this is also 30 degrees. Okay, so we've got, this is 6g and it is cos 30, and this is going to be 6g and it is sin 30. Right, so I'm going to, wrong thing. First of all, resolve perpendicular to the plane. So resolve perpendicular to the plane, and I end up with net forces is equal to 0. So I end up with R, and minus the 2 going downwards is P sin 30, and I've got minus 6g cos 30, and we know that both of those sum up to be 0. So I know that R is simply, and I know sin 30 is a special angle, is it's a half, so that's P over 2, and I know this is root 3 over 2 cos 30, so that is going to be plus 3g root 3, okay, because that's replaced with root 3 over 2. You could just use a calculator for that, doesn't matter. Therefore, you know, you could have just left it like that. Therefore, F max, was what we're after ultimately for this section, is equal to mu R. Now, mu I forgot to put on here. Mu, I believe it said was 0.4. Yes, it did, 0.4. Okay, so I've got 0.4, 2/5, 0.4 whatever, okay, times by P over 2 plus 3g root 3. Okay, and that's what we get for the F max. Now, resolving parallel to the plane, resolving parallel, let's say up is positive, with your net forces is equal to 0, then I end up with the driving force, which is going to be P cos 30. So P cos 30 minus the two opposing ones, which is this and F max, so the weight component, 6g sin 30, minus F max. Well, F max is 0.4 times by P over 2 plus 3g root 3, and we know that all of that is equal to 0. So again, cos 30 is root 3 over 2, so I got root 3 P over 2. I've got half, so that's minus 3g. I've got 2/5 times that, so 2/5 times that gives you minus P over 5, and minus 2/5 times that is going to be minus 6g root 3 over 5, and it is equal to 0. Now I'm going to times through by a single number 10, and then gather the p's on this side and throw everything else over. So times this by 10 gives you 5 root 3p minus, and this bit here is going to be 2p. Times this by 10, throw it over, gives you 30g. And times this by 10 is going to give you, throw it over, positive 12g root 3. Factorize this and you end up with 5 root 3 minus 2 is equal to your 30g plus 12g root 3. And then finally for that bit you got p is simply equal to 30g plus 12g root 3, and it is all divided by 5 root 3 minus 2. Okay, and we work that out in the calculator. So fraction button, first bit is 30 times 9.8 close brackets plus open brackets 12 times 9.8 times by root 3. Come out the brackets, go down, and then I've got 5 root 3, 5 root 3, come out the brackets, take away 2, and that gives us p is 74 point, what did it say to anything? Normal reaction observed by the plane and p. Right, so all I've got to do is write down p is 74, missed that again, 74.7 newtons. Okay, so that's that there. Now once I've got p, I can shove it back into here, and for part A I can say that r quite clearly is our unrounded answer shoved into there. So I end up with get my p, so store that as a, let's say, so shift stow a. Right, so all I've got to do is put that into there, so fraction by answer divided by 2 and plus brackets 3 times 9.8 times by root 3, come out, close brackets, press equals, and I get 88.3. So 88.3 newtons is the normal reaction to 3SF. Okay, and that was also 3SF. It didn't matter that we found this first and this second, no other way of doing it. Right, it says the horizontal forces removed show that the box will now start to slide down the plane. So this horizontal force is now removed totally. So I've got none of that going on. And all I've got to worry about is that enough to oppose now, because F friction will be acting there. And then the most we've got to work out what R is now in this fresh sense to find out what the new F max is. So we've got this new diagram going on, so I'm just going to rub everything else out. So those are our two answers so far. Okay, so just quickly rub this out. And scroll down, nearly there. Get rid of that E as well. Okay, so I've got this diagram just here in front of me, and it says show that it will move down. So that's what I've got going on now. Because this P was increasing the amount of R we got, it gave us a bigger F max, because F max equals mu R. So therefore I've got to work out this new situation. So again, I've got to resolve perpendicularly, and we do net forces. Net forces is equal to 0. So I end up with R, and it is simply take away 6g, and it is cos 30, and it is equal to 0. So R is, that's root 3 over 2, so it gives us 3g root 3, and therefore F max is 0.4 times that, which is 2/5 times that, which is 6g root 3 over 5. So with that being said, we can now simply look at that being F max. I can work that out, and we want that as a figure. Okay, so let's work that out. We end up with fraction 6 times 9.8 times by root 3 come out and go down, and I will have a 5. So the maximum friction is going to produce is 20.4 newtons. That's F max. So what we're going to do now is see what this component, the weight component, is, and if that is bigger than that, then it is going to slide down. Okay, so therefore weight component equals 6g sin 30. Well, sin 30 is a half, so that is 3g, so 3 times gravity. So let's just quickly show you what that is. So 3 times 9.8 gives you that, which is 29.4 newtons. Now because 29.4 is greater than the friction max that can ever provide, box will slide down. Down slope, and in fact, because there's an excess force going downwards, it would accelerate as well going downwards. Okay, but because the friction max isn't enough to hold it there. Okay, I hope that makes sense.